Okay. So the second test, guys, it's called test for independence. So just give me some time to explain this to you. I put a lot of details in there. You can read the notes, but I'm just gonna get into the heart, just of it and show you how to perform, this test. The test for independence is a test to check if two variables are related or not related. So if you are given two variables and you are asked to check whether the variables are dependent or independent, this is what the test for independence is. It is just like in section 10.1, a chi-square test. So you will compute, a test statistic called chi-square, and you will find the p-value, and based, on the p-value, you can decide whether to reject the null and the alternative hypothesis. I'm gonna just take you to an example right away. So the steps: state the null and the alternative hypothesis. To state the null and the alternative hypothesis for this test, your null hypothesis will always be the variables are independent. Your alternative hypothesis will be the variables are dependent, as you can see right here. And this is the null hypothesis. Then you will compute the test statistic. We're not going to do it by hand, so I'm going to show you how to use this one on the calculator. It is a chi-square test, just like the previous one, which is the sum of O minus E squared over E. This is going to be done in one shot using the calculator. Then we will find the p-value, and if the p-value is less than alpha, we reject the null hypothesis. If the p-value is more than alpha, we fail to reject the null hypothesis. And then we write a conclusion in the context of the claim. Here, guys, I put information on how to use a static range to run this test, but I'm going to show you how to use the TI-84 calculator in order to run this test. Okay, so we're going to begin with an example. I think it's very, very important to have your calculator ready, because it's going to be a special directions using the calculator in order to get this test done. And I will display the calculator shortly. So here is one. Let's begin with one question. And you guys, once you figure out how to do this one, you're going to be able to do all the remaining questions in the homework, because they're exactly the same. You just do the same process when you check if two variables are dependent or independent. So let's begin with this example. A medical researcher is interested in determining if there is a relationship between adults over 50 who exercise regularly and low, moderate, and high blood pressure. A random sample of 236 adults over 50 is selected, and the results are given below. Test the claim that regular exercise and low, moderate, and high blood pressure are independent. As I told you, the null hypothesis, the variables are independent. So what he's asking us is giving us the claim to be in the null hypothesis. So we just write it down. Regular exercise and blood pressure are independent. Can a student tell me what would be step 2, the alternative hypothesis? So that's HO. Regular exercise and blood pressure are what, guys?
Dependent.
Dependent, exactly. Or related. You can use the word related. When dependent, that means related. Okay. He says independent, so my claim is right here, guys. So the claim is right here. in the null. All right. Now, guys, you're going to pay attention in what we're going to do to find the expected values. These are called the observed values right here. So we need the expected value because the test statistic is this. So in order for the calculator to process that, it needs the expected values. And now I'm going to show you how to find the expected values. It's something we never done on the calculator before. So if you have your calculator handy, guys, please get it out and I can work with you as I do this. So I'm going to go step by step in using the calculator. All right, so let me bring the calculator up. Let's clear the screen. Okay. We will have to enter the observed values in the form of what they call it, a table or a matrix. A matrix, guys, is like a table. It has rows and columns. As you can see, we have a table here. How many rows of data do we have here? We have 2 rows of data. Don't count, the titles. We don't count the titles. So we have 2 rows of data. And can a student tell me how many columns of data do we have?
3.
3.
3, exactly. So it is a 2 by 3. They call it a 2 by 3 matrix. In order for the calculator to execute this problem, you need to be able, to enter the observed values as they appear right here on the screen. So a 2 by 3. And I'm going to show you how to do this on the calculator. So pay attention. You don't need to write notes because you already have the notes there. I explain on the TI-84 and how to do that, but just watch me carefully doing this. So turn the calculator on. You press second. Let's turn the calculator on now. All right. You press second and you can see what it says matrix right here. See the blue line? It's matrix right there. And then you go to edit right away and press enter. It's not difficult, guys. Once you know how to do it, you're going to see how easy it is. Okay. What do you think I need to enter here? It says matrix and it says 1 by 1, but I don't have 1 by 1. What do I have here? How many rows? 2 by what?
3.
By 3. And then start entering them. That's it. 35, 62, 25. This is what the calculator needs, and it's going to do the expected value by itself. You will see 21, 65, 28. Okay. Here you go. And now you can exit. Second. Maybe just quit. Okay, I'm going to do it again, guys. So you go to second. Matrix, that's very important if you are to use technology. Edit, and then press enter. If this is not 2 by 3, guys, change it to 2 by 3, and then enter the values. 2 by 3, and then enter, and here you go. Just start typing them in rows. 35, 62. You see the cursor moves horizontally, so it's in rows, and then you enter the values and then quit. Let's go to stat, tests, and scroll up. And guys, for section 10.2, it is chi-square test. It should be built on everyone's calculator, regardless whether a new or an old calculator, you should have the chi-square test. So press enter. It says, can you confirm that the observed values are in matrix A? Yes, we put them in A. Don't worry about the expected values. The calculator is going to do them for you. And I'm going to show you how the calculator compute the expected values. So it's always going to tell you, are the expected values in B? Just confirm that, guys. And there is nothing you need to do, just but hit calculate. Okay. So now chi-square is 3.47 and the p-value 0.1761. And the p-value. Okay, you agree with me, guys, that this is bigger than alpha?
Yeah.
All right. So fail to reject the null hypothesis. You're back to section 10.1 now. And there is not enough evidence at the 0.01 level of significance to reject the claim. I'm not going to write down the claim that regular exercise and low, moderate, and high blood pressure are independent. Probably this guys surprise you because you know exercise help lower blood pressure, but here we couldn't prove that. We say they are independent. They have nothing to do with each other. Probably because of the age, over 50, the exercise doesn't do much. I don't know, but based on what we got here, we say that we cannot deny that they are independent. All right. So now these are the observed values. What about if you were doing homework, guys, and you have a question, what are the expected values? For each observed values, there should be an expected value. So I have 6 observed values. I should have 6 expected values. Let me show you on the calculator how to get the expected values. You already have them. Remember, when we ran the test, guys, just let me show you here. The expected values, the calculator told us it's going to store them in B. So I'm going to show you what the expected values are. You go to second matrix. And do you notice, guys, now we have a new matrix that was generated and it's 2 by 3 as well. You just scroll down to it and press enter. And press enter again. And these are the expected values. And if you scroll right and left, you can see the expected values. The first one is 28.949, 65.65, 27.40, and so on and so forth. So these are the expected values. If you want to change the table of values to values with 2 decimal places, you could go to mode right here and go to float and make it 2 decimal places. Enter and watch. If I take you back to the expected values, let me quit. Second and matrix B. There you go. You can see, guys, now they are displayed with 2 decimal places. But I will always go back and change the mode to float. So I can get as many decimals as possible. Because sometimes he might ask you to figure out an answer to 3 decimal places. Well, definitely you don't want to keep it at 2 because it's not going to give you 3 decimal places. So this is how we use the calculator to perform the independence test. All right, we're going to go and do another exercise. It's example 4. A food services manager for a basketball park wants to know if there is a relationship between gender and the preferred condiment on a hot dog. The following table summarizes the results. Test the hypothesis with a significance level of 10%. Okay, step 1, stating the null and the alternative hypothesis. And HO, guys, would be the gender and preferred condiment are independent. As we stated, it's always the same. HA, gender and preferred condiment are dependent or related. Dependent means related, guys. Okay, can you guys tell me where the claim is here?
HA.
HA, because he says you want to see if there is a relationship. That means related. Exactly. Okay, step 2, find the test statistic. Okay, in order to find the test statistic, if using TI-84, input the observed values into a matrix. Okay, how many rows of data do we have here?
3,
And how many columns?
4.
Exactly. Let's do it.
So we would still put it in even though that 2 of those columns or a row and a column are just totals?
Oh, no, not the totals. You're right. Oh, I'm sorry. I didn't pay attention to that. See, I listened to you guys. Oh, we don't count the totals. These are not the data. The actual data are you're right. The reason why I put the total here to show you how to do this by hand, which I will do later. So I do apologize for that. So you were correct. So we have 2 rows, 1, 2. So don't count the totals, guys. Sometimes we give them to you, sometimes we don't. So 2 rows of data and 3 columns. Good observation. Thank you. Now we're safe. All right, let's do this. So we're gonna go second, matrix, edit, enter, and it's already 2 by 3. So good, we're good shape here. 2, 3, just change the values, guys. So 15, watch, I'm gonna go slow. So 23, 10, 25, 19, 8. There you go. And now you can quit. Clear the screen if you want. Don't worry about the expected values. They're going to be generated for you. So we go to stat, tests. So it's really not a difficult test if using technology. And I made sure all of your homework problems are p-values, are not critical values. So you can use this approach. So observed are in A, expected values are in B, and hit calculate. Or you can do a draw. Let's do a draw here. There you go. So the test statistic is 2.947. If he says 3 decimal places, it will be 2.948. And let's see what the p-value is, 0.229. Which is bigger than alpha, guys. Your decision is going to fail to reject HO. I'm sure you're tired already of hearing of rejecting, failing to reject. But as I told you, when we started chapter 7, it was all going to be about this. So fail to reject HO, and there is not enough evidence at 10% level of significance to at the 10% to support the claim or to conclude that gender and preferred condiment on a hot dog are related. Oops. All right, guys, so this is how you work out the problem. Do you have any questions? All right, so one more thing, just 1 second. To find the expected values by hand, you already have them now on the matrix, which I'm going to show you before we wrap this up. But you have 1, 2, 3, 4, 5, 6 observed values. You have to find 6 expected values. This is the total. 48 is the total in the row, and 40 is the total on the first column, and 100 is the grand total. So how can we use this data to find the expected values? For example, if you want to find the expected value of 15, look what you do, guys. You take the total from the row that 15 belongs to, which is 48. Then you take the total from the columns that 15 belongs to, which is what? 40. You multiply them and you divide by the grand total, which is 100. That will give you the first expected values. If you want to find the expected value of 23, guys, you will take the total from the row that 23 belongs to, which is 48. You multiply by the total from the columns that 23 belongs to, which is 42, and divide by 100, and so on and so forth. You have to do it 6 times in order to get the expected values. However, guys, when you did the method of the p-value, you already have the expected values, and let me show them to you. So if you go to stat now, let me just quit. If you go to second, matrix, and CB, it's 2 by 3, it's going to show you, press enter, here you go. You have the values 1, 2, 3, 1, 2, 3, 6 expected values. So you can get the expected values of the calculator. So if you're doing your homework online and you are asked to find the expected values only, you just put the values, the observed values, into a matrix A, and then you go and run the chi-square test, and then go back to the matrices, and then you're going to find that B was generated for you just like we did in here.